solving problems. It's using spatial algorithms, the latest and the greatest techniques in machine learning, statistics, and deep learning, as well as some of these tried and true, more traditional techniques to turn off data into useful and actionable information. So it's quite a heavy definition. But by the end of this presentation, I think you all will feel that most of the jobs that we do fall into spatial data science. So what is the difference between spatial data science and data science? I think there is rarely any difference. In GIS, we are building on those traditional techniques and adding the critical element of space. I will now request Rashmi to put the questions so that we can understand some of the capabilities that you already have. Rashmi, can you please put the questions? Rashmi, can you please put the questions?
Yeah, I'm just putting it. 1 minute.
Hello.
Rashmi, if you are having difficulty, we will put it later on. It's no problem. I'll continue.
The questions have been put.
Okay, great. So actually, I am not able to see the questions, Rashmi.
You need to click on the message box. People are answering it in the meeting chat.
Okay. Perfectly fine. So I got the answer for the first question, which are the data engineering techniques and data wrangling. Okay, good. Spatial analysis, no. So data engineering techniques are wrangling, geocoding, and geoenrichment. For visualization technique, most of the people have said mapping, but animation is also one of the visualization techniques. So if you must have heard of fly-throughs in 3D or 3D visualization of terrains. Okay, fair enough. So I'll go back to the presentation. Let us examine how people describe spatial data science and data science and what these two technologies actually stand for. So data science is the study of data. It involves developing methods of recording, storing, and analyzing data to effectively extract useful information. Now, I'm talking about data science, and most of people may be thinking this is all we do in GIS also. Okay, the goal of the data science is to gain insight and knowledge from any type of data, both structured and non-structured. Now, spatial analysis, as the definition says, is the process of extracting and creating new information about a set of geographical features to perform routine examination, assessment, evaluation, analysis, or modeling of data in a geographic area based on a pre-established and computerized criteria and standards. But if you look at other people, they describe that they don't see data science or as part of GIS, but they believe that GIS offers tools that fall in the preview of data science category. And to work with data science, you need to have data scientists need to have knowledge of coding, probably of R, Python, SQL. Now, the coding word that I'm referring here is scripting, rather than writing a software application here in this context. They believe that spatial data science is a discipline within the data science, which is probably not true because GIS involves a lot of things. What I really think is that data science and GIS, they have very common or overlapping tools and techniques that help both these disciplines, and they are actually not separate difference. They are not actually separate disciplines. So now, to build on our previous definition of data scientist, we can now define spatial data science as a discipline that allows us to turn the raw spatial data into an understanding, insight, and knowledge. So a spatial data scientist knows how to tidy, means clean, transform, visualize, model, and communicate a spatial data, which is similar to that of what a data scientist does. So if a data scientist is a journalist, someone capable of negotiating and bridging the main domain of data analysis and building models of complex data sets, then a spatial data scientist is someone who can do this in the spatial domain, and this is what spatial data science is. Spatial analysis or spatial data science is a data-driven analysis. Now, you can access spatial data from different sources, such as satellite images, tabular data, vector data, 3D, big data, LiDAR data, BIM, and even complex data like networks. The data can be as simple as a CSV file or a shapefile which is stored in a folder, or it can be as complex as a netbook in a relational database or a big data. Now, in GIS, or specifically in ArcGIS, we have categories or groups, functional groups, in which the complete tools of spatial data science has been distributed. Now, these groupings are, for example, data engineering, visualization and exploration, spatial analysis. Now, these three is something which most of us must have worked on: visualization, spatial analysis. But there are other functional groups like machine learning and artificial intelligence, big data analytics, modeling, scripting, sharing, and collaboration. So we will be talking about each of these functional groups in a very brief during this presentation. But in the later half of the presentation, I will be focusing more on machine learning and artificial intelligence. So what is data engineering? First of all, it is a very important initial step in data science processing. It is the phase where we collect and clean data so that it can be modeled. In fact, most analysts and data scientists spend most of the time cleaning and wrangling data that we call as data engineering. And it consists of data wrangling part, data cleaning part, geocoding, enrichment, and we will talk also about some of the readily available geospatial data that is available using ArcGIS platform. Some common type of data cleaning steps in data engineering can be just as simple as dropping duplicates or dropping highly correlated columns or fields that are no longer relevant to our study. You can also apply some scaling normalization on the data so that you can get the desired output result. One of the challenges that we face sometimes is the missing location, which is where the word geocoding comes in place. So we may have a beautiful address information, but if it doesn't have a location, that address information is incomplete for us. So this is where geocoding comes in place. Geo enrichment is another exciting data engineering process that most of us may have already done in our day-to-day work. It allows us to find new variables based on the location of our data and add those to your data sets, even if there is no obvious way of joining these two different tables. For example, say if we want to know what is the population of specific area within 15 meters, 15 minutes drive time from the hospital. Now these kind of analysis that gives us information about data that can be related is geo-enrichment. Now ArcGIS provides us a lot of content that is available on our fingertips. These contents can be easily accessible, and you can leverage mobile ready based maps and high precision imageries, use out of the box boundary and infrastructure data to build proactive models that include real time weather, traffic conditions, and even current events. So we can use all these maps that are readily available to use uh, in our work. Now, the next and important technique that we use, or area that we work as a spatial data scientist, is visualization and exploration. Now, there are three different kinds of tools that are available in ArcGIS or in GIS, which is mapping, charting, and animation. As a spatial data scientist, we visualize spatial pattern, trends, outliners, and anomalies in our data. We generate hypotheses and keep our analysis moving forward. Explore data to be sure that we're asking the right kind of questions. We view raw data and results as part of the iterative analysis process. In order for you to go and do this, ArcGIS provides you maps, charts, and animation to visualize your data. Visualization allows you to explore, understand, and find meaning in your data with dynamic analytical maps. You can bring together disparate data to see how things overlap and connect, visualize spatial patterns in 2D and 3D, validate your assumption, evaluate the results, and aggregate data within a map. Now, charting provides you interface to interconnect or interact with maps and dynamic chart linked to your data. You can compare categories in amount, visualize distribution and frequencies, explore relationship and correlations, and understand changes over time or distance. Interpret the results of your analysis and communicate the findings. So, as you know, pictures, they convey more than the words. So mapping, charting, and animation are important part of analyzing things or visualizing things in a better way. Now, in ArcGIS or in GIS, you can also visually simulate the movement of your data with 3D fly-through, time series animation, and real-time dynamic maps. You can view historical trends and real-time patterns over time and help decision makers and stakeholders understand what your sophisticated models convey. So as a spatial data scientist in spatial data science, we have something which is very important, and it takes us beyond simple visualization by interpreting location data into your analysis. It helps us in answering spatial questions using the most comprehensive set of analytical methods and algorithms available, uses multi-data formats, size, and scale. You can perform site suitability selection, you can find clusters, make predictions, and quantify how pattern changes over time. Create sophisticated statistical and mechanical learning models that unlock the full potential of your data. Now, there are various techniques that are available for pattern detection, space-time pattern mining, prediction analysis, suitability modeling, routing planning, route planning and logistics, terrain analysis. We will be talking very brief about these spatial analysis techniques. So, spatial analysis provides you a tool to dive deeper than traditional pattern mining, such as heat maps, know that patterns are real and spatial statistics, use analysis tool that quantify the spatial patterns to see in a defensible, report, reproducible way, apply data mining, machine learning, and statistics to find natural, spatial, and multivariate data clusters. It also helps you understand the immediate and long-term impact of your decision, integrate the temporal aspect of your data alongside the spatial aspect of your data, find out where things are happening. You can see how social and economic and environment aspect of a landscape is changing over time using space-time pattern mining. Now, in addition to this, you can use historical trends and additional information to cover trends and patterns and make spatial temporal forecast. Another important aspect is prediction. So you can make accurate prediction using powerful statistical and mechanical machine learning methods, as well as specialized spatial modeling approach. Use model interaction, flow, and movement in space and time to understand the patterns in the data. You can examine and quantify data relationship and forecast spatial outcomes. Now, suitability model is something that we probably most of us have done. Suitability analysis, it allows us to make the right decisions. We can use spatial tools and algorithms to find the best location, allocate resources efficiently, for example, meet demands and maximize or minimize the cost. We can combine domain expertise and organizational practices to model suitability and optimize location decisions. Route planning and logistics is another good example of spatial analysis. It graduates from simple point-to-point routing, like we can go beyond point-to-point routing and find out the path of least resistance and understand the cost of getting from one location to another, plan routes for an entire fleet. You can use ready-to-use networks that are already available on ArcGIS Online, and if you're using ArcGIS Enterprise, you can definitely use these facilities. This allows us to calculate travel time, locate facilities, and solve complex problems that are related to network specifically. Another important aspect of spatial analysis is terrain analysis that allows us to understand the Earth's topographic features, model and visualize the Earth's surface as digital 2D model and 3D model to calculate slope, aspect, curvature, delineate the watersheds, and compute visibility. You can use results to perform analysis and support decision making for a variety of applications using terrain analysis. Now, till now, whatever we have seen is probably very commonly used when you are working on GIS, but there are some new additions. So in fact, machine learning was part of GIS from the very old days, but it was not that highlighted earlier. As you see, and if you have worked as on remote sensing, specifically remote sensing data or satellite data in finding out, for example, objects or land use classification or land cover classification, if you have done using remote sensing softwares or digital image processing softwares, you will find that you've been doing machine learning, but there have been new additions to machine learning, which is deep learning, and we'll see how artificial intelligence, machine learning, and deep learning are correlated to each other. So to understand, machine learning is an application of artificial intelligence that provides system the ability to automatically learn and improve from experience without being explicitly programmed. Machine learning focuses on the development of computer programs that can access data and use it to learn from themselves. Now, we have a lot of state-of-art algorithms to make data-driven decisions that are already provided with the software, ArcGIS software. We can produce effective machine learning models by incorporating spatial data and location infusion algorithms. We can find natural cluster based on spatial distribution and attribute similarities, classify remote sense data, bring together data from different sources, formats, and scales to train powerful spatial prediction models. On the other hand, deep learning is an artificial intelligence function that imitates the working of a human brain in processing the data and creates patterns for use in decision making, also known as deep neural learning, or deep neural network. Now we can use spatial data science. You can create sophisticated models that learn from massive data to solve problems. Using deep learning spatial data, scientists take advantage of the latest advancements in artificial intelligence to reduce human error and increase the chances of finding objects that are hard to see with the human eyes. In addition to this, now traditional data science and artificial intelligence have come together along and can be integrated to solve complex problems by combining powerful ArcGIS built-in tools with any machine learning package or framework that includes, some of them are TensorFlow or IBM Watson and Microsoft Artificial Intelligence. Now, very recently, there have been new developments, and big data analytics has been incorporated into spatial data science. There was a need that gave birth to this kind of addition to spatial data science. So let us understand what is big data. Big data is basically a phrase used to mean a massive volume of both structured and unstructured data that is so large that it is difficult to process using traditional database and software techniques. In most enterprise scenarios, the volume of the data is so big, or it moves so fast, or it exceeds the current processing capacity. So let me give you an example. Like, for example, most of you or almost everybody uses Google Maps, like for example, and you use it for driving directions or traffic. So there is constantly information that is being sent to you from the servers, which is updating on the traffic. So how do you get this information? Now you get this information because your cell phones, where you have these applications installed, they are sending your location information probably after every short interval to these servers. And what these servers do is they take your location information and they snap the location information with the road features. So once they snap the or road segment, I would rather say. So once they snap this information with the road segment, they use certain algorithms to say that it is high traffic, medium traffic, or low traffic. Now, this result, which is being collected from, say, for example, thousands of cell phones, and every second, every like 10 seconds, this information is being sent by your phones. So there are thousands of phones that are sending this information. This information is being collected on and analyzed, and then that information is sent back to you as traffic. So in order to handle this kind of massive data, you need to have a different technique. Relational database won't work. So that's why we have big data. ArcGIS provides tools to transform massive spatial data into manageable information. It allows you to use the distributed architecture to analyze and display large volume of data. Ingest real-time data from sensors, social media, IoT systems, and and use it for geospatial analysis. Now, ArcGIS software helps you to reveal spatial patterns by generating on-the-fly data representations. One example is here. It's a small video that I'm playing right now. So you can see this data that is animated and auto aggregate as your real-time data streams. You can use time as a variable to visualize massive data sets in 3 dimensions also. Spatial data science use distributed computing to analyze data that was previously too big or complex, identify data patterns that were previously hidden in noise, find clusters of events and hotspots of activities, use regression tools to find relationship between data sets and predict future events. You can make sense of the massive imagery that you have collected or it's part of your collection. Use distributed processing and deep learning for object detection, classification, terrain analysis, and change detection on a global scale. Big data tools ingest data from sensors, social media feeds, IoT system, analyze real-time data as it streams and triggers alert as it moves or change. And this all can be achieved using drag and drop tools in ArcGIS to configure, design, and deploy your real-time analysis workflow. Now, modeling and scripting is next functional group that we as data scientists or data science tools that are available in GIS is used by most of us as data scientists. We can automate spatial analysis process, reduce the chance of error, and make jobs easier and faster. We can add new functionalities to ArcGIS using Python and integrate with other data science modules and packages to solve any problem. It helps us in saving time on respective tasks, minimizing errors, and iterating on your analysis more efficiently. We can create end-to-end workflows by chaining the models and spatial algorithms together into a single process. Build fully functional models without a line of script using a visual model builder, or we can use Python to script our workflows and create ready to share models. Now you can also communicate this to your on the organization level, so it gives you transparency and you can reproduce it. You can drive analytics forward in your organization, clearly articulate your analysis and analysis methodology to add credibility to your work, and you can build this simultaneously within the process and document it. So whenever you are sharing this, and this can be done using your built-in Jupyter notebook that integrates your metadata tools and visual modules also. So the last and the foremost thing, and which is very important as far as the work is concerned, that is the sharing the work or collaborating while working. So sharing the work that you've done or analysis that you've done to the decision maker is very important. So ArcGIS platforms allows us to share our work to everyone anywhere. We can work with our colleagues on analysis projects and share analysis workflow, communicate results, and enable others to perform the same analysis task to make more informed decisions. We can work collaboratively and share analytical models, results, and tools securely with our team, organization, and members outside our organization using ArcGIS enterprise, and we are empowered. Can empower the experts to share their analysis work with others so that others can also take benefit of it. We can infuse analytics into our organization's decision-making process by making our models enterprise ready and accessible. Now, algorithms, they give us answers, and decision makers can understand the answers. But in order for answers to be understood by a larger audience, we need to deliver those answers in form of stories. Now, this helps decision makers to get most out of our analytics or analysis and turn sophisticated analysis into a compelling story. And this can be done using built-in storytelling capabilities that incorporate text, images, and videos. So we can share our work uh, with narrative and with all the information that we want to convey to our colleagues, clients, and to the public. Now, I think let us hear what others have to say about spatial data science. So this is a it's a short video that I will be playing, and hope whatever I've tried to convey in the previous slides, you can also hear what other people say about it.
In a lot of ways, it's the intersection between GIS and data science.
Not only knowing where things happen, but if something that happens in a certain place depends on what happens in the surrounding area. Focus also on this spatial component, which oftentimes explains a lot of why things happen.
So right now, at the moment, we see a lot of traction in retail, especially for revenue predictions and site planning. We work also with utilities to help them predict the churn in their customer portfolio. We also work with financial institutions to help them analyze the performance of the different businesses in order to study potential investment.
Other common analysis would be to analyze, for example, mobile patterns to understand where people move, for example, for targeting some marketing campaigns using billboards, for example.
I think transportation is a area that use spatial technology, spatial data science a lot.
Identifying hotspots in roads where accidents happen, for example, solar fan installations. So identifying where you can find more people with a higher propensity to install those sort of solar panels.
Maybe also urban planning, cities, governments are going into it a lot too.
I feel like in real estate and private equity, there's tons of demand for it. Just a very small increase in the accuracy of their model could result in millions more in revenue for them.
Geomarketing, revenue prediction, and twin area analysis.
So in terms of spatial data streams, we're working a lot with global demographic data, also with financial data that shows you where people is spending the money and where those consumers are coming from. Human mobility data, similar, but only in those areas where people are visiting. We work also with point of interest data, global boundaries, environmental, and road traffic.
Point locations, addresses, maybe GPS coordinates, or if it's coming from, I don't know, maybe aerial images from sensing.
I think my major, my primary language is Python. So in terms of the data processing part, like a normal data scientist, we use NumPy, pandas to kind of processing the data and also to clean the data. And also we use partial frames to visualize the data and to find the patterns of what the data looks like from your original data set.
You can use everything from ensemble models to neural networks, deep learning.
So pandas and GeoPandas, PySouth, for example, which is also specific for spatial data science, NumPy, sklearn, the SciPy environment in general.
We do a lot of problems in clustering, so spatial clustering. So there are a lot of traditional data science clustering techniques that work in the attribute space. But for a lot of the spatial clustering techniques, you need to work with problems such as contiguity.
Processing data, cleaning data, a lot of the boring stuff that people don't really talk about when talking about spatial data science, and then actually modeling.
Another kind of major subtype of problems that we work on are optimization problems. And so some of the ones that I've worked on in the past are logistics oriented. So you need to understand properties of the road network, connectivity, how long it would take to get from A to B.
There are lots of challenges nowadays gathering spatial data. First, because there are lots of different types of data. and usually they don't come into one single place. You have to go and look for them source by source. The other problem is that they come into different aggregation forms, so you need to first gather all these different data sources and then bring them to the same spatial support, as we say.
Another one is the fact that sometimes some of the data streams have anonymization in place, so we need to apply some specific measures to go over it, and then also the sampling bias. So some data is collected from sources that don't have the full population at hand, and then we need to understand and work around the possible bias that the data has.
So trying to hire spatial data scientists is pretty hard. I would say finding people with the skills and kind of that sweet spot is hard.
To be a spatial data scientist, I think you need a background of statistics, also have a good programming skills. It's better to have a deep understanding of what happened in the urban intelligence area.
There are not many data scientists that knows about spatial analysis and spatial data in the market. Typically, spatial modeling and spatial data has been a field that's been developed a lot in academia, but not so much transferred to the business sector. There still is a transition, I think, between the GIS type of analysis to more type of data science analysis using spatial data. You can look on LinkedIn for them, but I don't think you can find many people with the spatial data scientist job title.
This is definitely a fast-growing industry. So we see a lot of interest at the moment, but then when it comes into adoption, we still are facing some challenges. So we are helping on that, but what we predict is that there's going to be more and more organizations that they will are starting to create their data science practice in-house, and that then what they will have to, they will need will be the right tools and the right data, and they will be fully capable to doing the analysis themselves.
So, welcome back. In this coming section, we will learn more about artificial intelligence and machine learning tools in ArcGIS, specifically the techniques that we have or tools we have related to imageries. Rashmit, I request you to please put the second set of the questions. So we have now 2 more questions coming in. Rashmit will be adding those questions on the chat box. And after that, we will be talking about a list of jargons that we almost hear every day. Artificial intelligence, machine learning, deep learning. Some of the terms CNTK, neural networks. So the questions are, the machine learning tools from the following. It's got 3 responses for classification, clustering, somebody added in. The second question is examples of machine learning using satellite imagery, object detection, well, got 3 for object detection. Why not classification? Do you think classification can also be a machine learning technique or example of machine learning? And use classification. Okay. Great. So artificial and machine learning are some of the most important and fascinating concepts in today's world. You see a lot of terminology thrown around, which is like object detection, random forest, CNTK, machine learning, deep learning, and all the buzzwords that can get confusing, especially when we are trying to find right tools to solve the spatial problems that we have. So today we will boil it down to the three main ideas. And these three main ideas are artificial intelligence, machine learning, and deep learning. So as I said, machine learning is one of the techniques of artificial intelligence in in the earlier presentations. Artificial intelligence broadly describes how a computer or a machine can do a task that requires some level of human intelligence. And one of the engines that makes it possible is machine learning. Now, machine learning is an application of artificial intelligence that provides systems the ability to automatically learn and improve from experience without being explicitly programmed. It deals with data-driven algorithms or techniques that learn from data to find the information you need. And one type of machine learning that has emerged in the past few years is deep learning, which has to do with code structures that loosely resemble the human brain and how adaptive it is at solving problems. Now, deep learning techniques can drive machine learning, which then ultimately enables artificial intelligence. Some of the terminologies or some of the artificial intelligence that is commonly used in today's world is natural language processing, computer vision, video game behavioral AI, and robotics. Machine learning, there are several techniques or algorithms that are available for classification, clustering, um, uh, for object detection. These could be maximum likelihood classification methods or vector or support vector machine methods. Whereas deep learning, it has again several other tools like TensorFlow, Keras, IBM Watson, and um, so these all together have been combined and brought into ArcGIS. Let's see how ArcGIS actually handles machine learning. So you can perform classification, prediction, clustering, and now deep learning within ArcGIS. Classification is a process of describing to which category an object should be assigned based on a training dataset. ArcGIS includes many classification methods focused on remotely sensed data. These tools analyze pixel values and configurations to categorize pixels. Some examples include delineating land use type or identifying area of forest loss. Prediction is about using the known to estimate the unknown. ArcGIS includes number of regressions and interpolation techniques that can be used to perform predictions. Applications include creating an air pollution surface based on the sensor measurements and estimating home values based on recent sales data and related home and community characteristics. Clustering is again another technique that we use in ArcGIS machine learning tools. It's the grouping of observations based on similarities of values or location. And ArcGIS includes a range of algorithms that find clustering based on many attributes, location, or combination of both. Now, deep learning. There are many key additions within the Esri to advanced machine learning methods and integrated approaches across the platform, including deep learning methods such as random forest, neural networks, logistic regressions, and time series forecastings are available in ArcGIS. It has also simplified user experience by integrating with popular machine learning libraries and packages. Now, let us see some of the examples of these machine learning tools that are available in ArcGIS. For example, let's take an example of classification tools like pixel and object-based image segmentation, maximum likelihood, random tree, support vector machines. So if you want to know more about these classification, I can share you URLs that you can study about these classification tools, classifications and how they work. From classification to cluster to prediction, ArcGIS has a series of tools that already use machine learning in their algorithms. ESRI has actually had machine learning algorithms in geoprocessing tools for many years. By necessity, we have had these tools to solve geospatial problems like clustering. I remember Thomas gave a presentation where he specifically talked about hotspot analysis and real-time pattern mining, space-time pattern mining. And if we want to get into each of these, it is a separate presentation in altogether. It should be as what Thomas did in his earlier presentation. So one area of AI where deep learning has done exceedingly well is in computer vision, the ability of the computer to see. This is particularly useful as satellite and aerial, or useful for GIS, as satellite, aerial, and drone images is being produced at a rate that makes it impossible to analyze and derive insight from through traditional means. Object detection and pixel classifications are among the most important computer vision tasks and are particularly useful for spatial analysis. And some of the inbuilt tools that we have in ArcGIS for deep learning is generating training samples, detect objects, and classify pixels. So in ArcGIS, we have machine learning tools that help us in generating or deriving structured information products. Now, these products help us in a lot of areas such as asset management, identifying agriculture yield, fleet management, identifying targets, performing suitability analysis and change detection. In general, imagery is in raw form is an unstructured data. Combining the power of ArcGIS and machine learning, we can transform this data to geospatial information products. You can derive results and actionable information from this data. And that is specific to many applications such as for precision agriculture. Using ArcGIS, you as data scientists and engineers and even remote sensing experts can derive structured information products that can help solving geospatial problems. So there are various kinds of workflows, machine learning workflows in ArcGIS. We will be talking about 3 different kinds of machine learning workflows here. The first workflow is when you receive a trained model for an imagery. Now, these workflows are specific to imageries. We received a trained model, which probably was developed by some data scientist. Once we receive it, we use inferencing tool and the imagery, satellite imagery that we have to run this model on, and finally we get an output. Now, ArcGIS provides us tools that helps us in managing these satellite imageries. It also gives us capability to share the models that have been developed outside using different deep learning techniques and by different data scientists. And once we receive these models, it can be shared through portal. We run the model against the imagery and we get the output, which could be a raster or a feature. It also gives us capability to render this output dynamically over the screen, and you can navigate through it and save it as a new product. Now, the kind of softwares that you need or Esri softwares that you need for this is ArcGIS Desktop, ArcGIS Enterprise, and probably an imagery server. Now, the next workflow is where you have to include or create the training site or training samples yourself. So the creation and export of training samples are done within ArcGIS Pro using the standard training sample generation tools. The deep learning model is trained with PyTorch framework using the train deep learning model tools. Once the model is trained, we can use the Esri model definition file to run within the inferencing georeferencing tool. And we can run this on the satellite image that we have selected as an input and visualize the same, visualize the output in ArcGIS desktop dynamically. Now, the third and the foremost important machine learning workflow is where we are incorporating deep learning along with the inbuilt capabilities of machine learning tools that we have with ArcGIS. So training samples of features or objects of interest are generated in ArcGIS Pro with classification and deep learning tools. These training samples are used to train a deep learning model using georeferencing tool, geoprocessing tool, and the resulting model definition file or deep learning model package is used to run the inferencing geoprocessing tool to extract specific object location or classification or label the objects or classify the pixels in the imagery. Now, in order for us to do all or to run these workflows, ArcGIS provides us state-of-art tools which are easy to use. So in case of a classification that we are trying to impose on imagery, in supervised image classification, we need to train the classifier to assign pixels or objects to a given class using the training samples. The class category are determined by your classification schema, and the training samples can be generated using the training sample managers pane. Tools in the training sample manager pane allows you to create training samples for each class category in your schema and provides information about the number and the size of the samples to help you improve the accuracy of your classification model. Now, there are 5 different classifications available to classify your data, but by large, people use maximum likelihood classification, random tree, support vector machine. And in order for you to use any of these classification methods, you can use widgets that are provided in ArcGIS to perform image classification. It is segment or object-based classification techniques. You can use a training sample manager to create training site and manage your training sites. In order for you to confirm whether the training sites that you have selected will give you an appropriate result, there are accuracy assessment tools that you have to run on your samples so that you assure that your site selection is correct. There are various examples of machine learning that are listed here: change detection, regional planning, land cover classification, flood planning. So there are also examples that I have listed here which are from deep machine learning, which is probably environmental compliance, legal compliance of your residence or your property, emergency management or damage assessment after a catastrophe, retail predictions, transportation networks, and there are endless possibilities of using machine learning or artificial intelligence in GIS. Thank you very much for your patience, and I hope this session was useful.
Thank you, Nishant. Please, everyone can write their questions in the comment box if they have any. Okay, so we have questions coming in. Do you need to have high programming skill to do spatial data science analysis in ArcGIS, or we can do it using the available ArcGIS tools?
So the answer to this question, if I've understood correctly, is you need to have knowledge of script, Python specifically, and using TensorFlow or Python. The notebook provides you a combination, or it's an integration interface between ArcGIS and TensorFlow. And using Python, you can do it if you have a good understanding of Python, and that's more than enough for performing analysis in GIS.
Okay. Anyone has any more questions? I can see Kishore sending a link. I don't know what this link is for. Okay.
Was done by
Yes.
SRI starting from February second week, and this mock was ended around March. So it gives you almost everything that I've spoken about. If you want to do these exercises of this mock, I have all the exercises as well as data. So if you're interested in going through on the exercises and data, I can forward it to you.
Does anyone have any more questions? Okay, so as usual, I'll be sending down a feedback for this knowledge transfer. Please do give in your inputs, and we'll be seeing you on Monday. Monday, we have the next scheduled session. Thank you so much, Nishant, and thank you all for joining in.
Thank you, Rashmi and the team. Thank you very much. Bye-bye.
Bye.